Hello, my friends. This is Mr. Folly again, and welcome. Oh, good, we're in a different color. To part two of number one. So I got through 1 through 4. We did a handful of them in class. So let's just keep on trucking along. A kinetics experiment is set up to collect the gas that is generated when a sample of solid calcium carbonate is added to a solution of ethanoic acid. The rate of the reaction is determined by measuring the volume of gas generated at 25 degrees Celsius in 1 atmosphere as a function of time. So we're doing the volume as a function of time. So that's volume over time. Usually it's molarity over time. That's it. Describe each of the following would affect the rate of the reaction. Explain your answer in terms of the collision theory. Decreasing the volume of ethanoic acid used in this experiment. So decreasing the volume of ethanoic acid. That would be no change because the concentration is constant. So if I have 100 milliliters of 2.0 molar or 50 milliliters of 2.0 molar, the concentration is the same. So remember we did our sugar cube lab thingamabobber? The big beaker of water did not dissolve it faster than the medium beaker of water. Does this change, increase or decrease the rate of K? It's going to be the same, which I said don't worry about that yet, but it'll be the same. It's always the same unless you change the temperature. Decreasing the molarity of ethanoic acid. So decreasing molarity decreases concentration. So collisions per time goes down. So rate goes down. And I want to emphasize collisions per time and rate. So you want to add the per time. I'm bad about remembering the per time, so hopefully I remember, or you can call me on it. And that's it. K, no change. Increasing the temperature at which the experiment is performed. So if you increase the temperature, that would increase collisions per time and the energy of collisions. So there will be more successful collisions, more successful collisions per time. So I'm supposed to actually say rate. Would affect the rate. Successful collisions per time. So increase rate. If you increase the temperature, increases K. Does the temperature at which the experiment decreasing the temperature? So it's the opposite. Decrease collisions per time and decrease energy. So fewer successful collisions per time. So rate goes down. Decreasing the particle size by grinding it into a fine powder. What that does is that increases the collisions because more places for collisions. So it increases successful collisions successful collisions per time rate increases. What are the conditions for the collision theory? Ooh, the conditions for the collision theory. Conditions. You got to have a collision. You have to have enough energy. Oops, I put E energy. EE. Not what I want. Enough energy and the proper orientation. Define activation energy. Energy required to complete a reaction. And remember how I talked about it being a hill you have to climb, or in one class I talked about having enough energy, the activation energy to dunk was to jump high enough, or whatever it was. Explain the various ways a reaction can be unsuccessful according to collision theory. Particles don't hit. Oops. I'll change that to no collisions. too little energy. Improper orientation with a collision. Explain how increasing temperature can increase the rate of reaction in terms of the collisions. Particles move faster, so increasing T means particles move faster. Particles move faster, so more collisions and more successful. Isn't it annoying to have to write successful collisions per time? So, whoops. So, rate up. Activation energy. Activation energy is the same. EA is the same. But increasing temperature increases the number of particles with enough energy to react. So rate goes up. So when an increase in the concentration of a reactant may lead to an increase in the reaction rate according to the collision model, indicate if the rate constant K is increased or decreased. K is constant. So that's it, unless you change the temperature. So what do we say? Increase in the concentration. Increase concentration increases collisions per time. So successful collisions over time increase, so rate increases. If your hand hurts from writing this, so does mine. Explain why at a constant temperature an increase in pressure of gas causes an increase in reaction in terms of the collision model. Increasing pressure increases number of collisions per time, so rate increases. So a greater pressure means there's more particles around, so they're going to boom, 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 knock into each other. So does that increase in pressure increase or decrease the rate constant K? K is only changed by temperature. Okay, know that. Use the figure below to answer the questions that follow. Temperature 1, temperature 2, activation energy. Hey, happy Boltzmann, everybody. Which is at a higher temperature, T1 or T2? Justify your answer by referring to the figure. T2 has more particles with higher energy. Which would have a greater rate of disappearance of reactants, T1 or T2? Explain your answer by referring to the collision theory model. Okay, so T2, because more particles have enough, oops, oh man, guess can't erase it, enough energy to react. That's greater than EA. Does temperature affect the rate constant K? Yes. And here we go. In the box on the left is a picture of a solid sample of Mg and the strong acid HCl reacting. In the box below on the right, draw a picture of Mg with a smaller particle size reacting with HCl. Use your picture to explain why magnesium with smaller particles will do that. So I'm going to call this Mg. Oh man, where's my giant dot? This is Mg. So now I'm going to spread out my Mgs. Oh, look at how they're dancing all over. Okay, so if I do this, what happens is before the H3O, whatever they are. Oh my goodness gracious, St. Ignatius. These guys, the HClO3s, had to touch them. So now I'm going to use this for my H3O positive. Oh man, it's moving my dots around here. So on the box below, on the right, draw a picture of Mg with smaller particle size reacting with HCl aqueous. Use your picture to explain why Mg with smaller particle size. There are more places for reactions to occur. Collide and occur. Good. In a lab to determine the percent copper and brass, long ribbons of brass react with nitric acid. The teacher explains that you could have also used small shavings instead of long ribbons. However, the shavings don't work as well because the nitric acid bubbles over. Explain why using the small shavings bubble over. More places for collisions. So rate is up and bubbles form too quickly. How does the rate of disappearance of a reactant change with increasing strength of covalent bonds? How's the rate of disappearance of a reactant with increasing strength? So stronger bonds have a higher EA, so it takes longer to break them, and rate is slower. All right. 17, two elementary steps below are carried out at the same temperature. Reaction 1 takes longer than reaction 2. It says slow. I believe that. Assuming no difference in correctly oriented collision, explain one reason why the reaction would take longer. I have to explain one reason. Okay, so one could be colder. So fewer collisions yield slower rate. I could also have fewer particles with enough energy. What could be colder? There you go. That'll finish part 1. Toodles.